My name is McGavren, and I am here to talk about teaching tech. Pardon me while I mess with the clicker here a little bit. Oh, wrong big green button, my fault. Okay, there we go. I am the author of Head First Ruby and Head First Go, both books published by O'Reilly. I also have a total of 4 years experience creating online video training for Code School and then Treehouse. Why should you listen to me on this topic? I don't know. I don't really feel like my content should be that extraordinary. But here's the average rating for Head First Ruby on Amazon, and here's the average for Head First Go. So I feel like I must be onto something here. This talk is my attempt to share how I work with you. My Bible in this regard is Efficiency in Learning by Dr. Ruth Clark and Company. It's a set of guidelines for teaching methods, and it's research backed, so it's got plenty of citations to back everything up. One of those first guidelines is to minimize page flipping, and you've probably experienced this. You need context for everything that you read in a book. If you have to flip back 3 pages or worse, 300 pages to get that context, you're wasting mental resources that you could be devoting to learning. So you want to avoid that. My mantra that I developed in this regard is do repeat yourself. In Head First Go, for example, I didn't tell readers to refer back to page X. I copied content from page X onto the current page. I did this often enough that I wound up coming up with a torn page effect to make it clear which portions of the page were repetitions. Another guideline from Efficiency in Learning, avoid split attention. That happens, you've experienced it when you've seen a diagram in a book and you have to look at the paragraph before it or after it to even understand what the diagram means. You don't want to make readers look all over the page to assimilate information. You want to put the related information together. Here, for example, is a quick tutorial in the printf function. You got a table explaining different printf verbs. You've got a code sample demonstrating those verbs, and you've got the output for that example. But what you could do is you could integrate everything together using comments. You could put the verb on a comment right before a line of code demonstrating that verb. And you can even put output onto the same line. I've seen this technique demonstrated first in Programming Ruby, the book Programming Ruby. You just put a little arrow showing what the output of a line of code is right there on the same line. Another thing the Head First series does to avoid split attention, yeah, sure, we have code samples with paragraphs of text before and after explaining them, but we also put annotations right there in the code samples, again, to assimilate everything together. It's a lot of effort, but you can come up with something almost as good using comments. Just put a comment right before the line of code you need to explain. Something I've discovered is that it's important to break topics down as far as you can. Head First Go included a number guessing game, which was really motivational to learners, yes, but it had a lot of skills you had to use. There was reading strings from standard input, converting them to numbers. They needed to master if statements, random number generation, and for loops all at the same time. It's a big code sample. And if they got any of those items wrong, they'd have a big program to debug. So I came up with a separate, smaller grading program that used many of the same skills, but a smaller part of them. That way they could be confident in that portion of the program before they had to go on to random number generation and for loops that they needed for the guessing game. It's important to anticipate viewer questions. So here, for example, we've got a use of printf to round an excessively precise floating point number to a certain number of decimal places. Well, that could create the question in the reader's mind. What happens? Does printf just truncate the number, or does it round it up where it's necessary? You don't want to leave them wondering about that sort of thing because, again, it's distracting them from their main task, learning. Anticipating and answering this sort of questions, it instills the reader's faith in the technology you're trying to teach, the Go programming language in this case, and it instills faith in you, the teacher. I can't tell you the number of times I've been thanked and gotten positive reviews for anticipating readers' questions as soon as they came up with them. Fixing it in this case, it's as simple as adding one more line of code to the slide demonstrating a number that needs to be rounded up and showing that it gives you the appropriate output. It's important to leverage existing knowledge wherever possible. It'll save your readers mental effort by basing new learning on concepts they already know about. Of course, you need to make sure they know about the concepts that you're basing it on. If you're teaching Python or Ruby programmers, for example, and you're trying to teach them about Go maps, you can just compare it to dictionaries or hashes. If they've never heard of dictionaries or hashes, you might need to be a little more clever in coming up with your metaphor. I use this in Headfirst Go. I showed that a slice is like an inbox, and if you want to find something in it, you got to start at the top and search the whole pile. Whereas a map is more like a file drawer. If you want to find something, it's already indexed for you by the keys, and you can find it immediately. It's important to offer practice for your learners so that they can cement what they've learned. But not all practice is created equal. For example, if you need to teach them about interfaces, well, here we've got a whole list of steps that they need to do for this exercise, and half of them are devoted to writing up the type and the methods that you're going to write an interface for. Whereas right now, what they need to be practicing is interfaces. It'd be better if you could focus them on that. One way to do that is a fill-in-the-blank type exercise. You write the type up for them, you write the methods that they're going to write an interface for, and their only job is to create the interface type and maybe a function that relies on that interface. You can even literally provide blanks for the reader to fill in if what you're doing is more syntax-based. Now, I could go on about this, but my time is limited, as that chime indicates. So here's some further reading where you can go and read up on these ideas for yourself. Now, this is going to go by really fast, but I also just tweeted a link to these slides, which includes all those resources. Now, I mentioned it was important to offer your listeners practice, so your practice is to look up these resources and incorporate some of these ideas into your next talk or training. Thank you.